Okay, so let me start off first by thanking Martin and everyone else involved in putting WebGL Camp Europe together. I'm sorry I can't be there in person, but I really appreciate the opportunity to present virtually. So let me introduce myself. My name is Matthew Amato, and I'm a software developer at Analytical Graphics Incorporated, based outside Philadelphia. And, I also have the opportunity to work on this project called Cesium. And the presentation today, as Martin said, is Cesium language, or as we call it, CZML. And we call it a JSON schema for describing dynamic scenes in virtual globes and maps. So let's start off. You might ask the question, well, what is Cesium? Before we talk about CZML, you probably want to understand the project a little better. And Cesium is a WebGL-based globe and map, and it's developed in the open under an open source Apache license. For those of you not familiar with the Apache license, it's a very liberal license. So you can develop commercial closed source software with it or open source software. You can do almost anything you want within reason. All of the code is up on GitHub. This is a shortened URL, git.io/Cesium. And, my presentation is also up there today. So if you go to the main page and you want to follow along, you can go to our wiki and find my presentation. All of the demos I'm going to be showing are also live and on our website. So if you go to cesium.agi.com on your laptops, if you have them, you can run the demos yourself instead of seeing them over Skype. That being said, I'm going to jump right into our first demo, which is Cesium Viewer. And this demo, what I want to illustrate here is a simple application written with Cesium. Now, Cesium itself is the 3D rendering engine, and that's what you see in the canvas in the background here, this virtual globe. Cesium doesn't go outside the canvas, so this toolbar, these buttons, the logos, everything you see there, that's built on top of it, and that's the application. So in this case, it's our reference application, Cesium Viewer, which just lets you browse around the globe. We have streaming imagery loaded here. This is actually Bing Maps, so we can, but we support other formats, WMS, OpenStreetMaps, Esri services. Show you guys, I'm right here in this region. See, we can zoom in and out. In addition to being a 3D globe, we also have a 2D mode. So now you can actually, it's just a 2D projection. And we also have a new mode we call Columbus View.
Matt, I have to interrupt you quickly. There's a problem with screen sharing.
Okay, can you not see my screen, or?
No, I can't see your screen at the moment. I think I hang up and call you again, maybe.
All right, hold on 1 second.
Or do we see a button or something?
Okay, still here. Let me try and reshare here. You have anything?
No, I can't see. We only see.
Okay, let's stop, and I'll stop and call me back then.
Okay. We tested this yesterday, but always there are some problems if we're doing this live.
Okay, I can see you. Can you see me first?
I can see you and hear you, yes.
Okay, so let's try screen sharing. Share screens. Start. See anything?
No. Now I can see. Now we can.
Now
see.
you can see.
Perfect.
Oh.
Yeah. I changed the full screen.
Let me try something.
Okay.
I think this might be okay. Let's try it again. Can you still see?
Yes, we can see. Perfect.
Okay. I think actually the problem was WebGL. I had Angle turned off in Chrome, which was using the OpenGL renderer, and apparently that was making the video go blank. So as soon as I restarted Chrome with Angle, everything worked fine. So DirectX wins that round, I guess. So as I was saying, this is Cesium Viewer. So everything looks fine now. And, it's a globe. It's also a map. We have streaming imagery. You can change. We support a variety of different formats. So, for example, we have Bing Maps showing here. We also do WMS and Esri imagery. And we're looking to add new formats all the time. We have a plugin system for different streaming imagery. It's also a 2D map. So you can view the world as a 2D projection. And then it's also we have Columbus View, which is a new format. You can think of it as 2.5D. So it treats the world as a flat Earth. So it's a flat Earth projection, but you're still viewing it in 3D. So, as if you were going to fall off the edge if you, went to the edge of the world. So that is the general gist of cesium. Now, some of the key differentiators here are that we take time very much into, that's a first-class citizen to us. So if you look at this globe, as I animate and I scrub back and forth, you can actually see that we're changing the position of the sun. So we're accurately modeling the sun, and I can animate here, and we're accurately modeling time. So as I animate, you're going to see the day-night cycle, begin. So that's general. We'll get to plenty of more demos, but this is just Cesium Viewer, reference application built on top of Cesium. So now that we've looked at Viewer, you understand a little better about what Cesium is. One of the important distinctions is it's one API. We have an API that covers 2D, 3D, and Columbus View, that new 2.5D. You only have to code your data once, and you get visualization in all the different formats. We specialize in precise dynamic data, so not only is the data changing with time, but we can also handle very precise data. So whether it's deep space satellites or things really modeled close to the ground but in close proximity to each other, we try and keep everything highly precise. So in reality, it's kind of split into 3 different layers of abstraction. So at the lowest level, we have the rendering layer, which is a JavaScript API built on top of WebGL, similar to like 3JS or SpiderGL. You might be familiar with those. And what it does is it raises the level of abstraction on top of WebGL to just make it easier to use and provide you a rendering layer to make it easy to do low-level rendering. And then built on top of that is a mid-level scene layer, still a JavaScript API, but now it's more akin to like Google Earth or Google Maps, where you have an API that allows you to create lines and markers and move them around the screen and different imagery, eventually models. So this will let you kind of work at a slightly higher level, and it positions everything in a real world. So it's very easy to have real world scenes. And then at the highest level, we have this new format. It's a JSON schema, and it creates data-driven visualization. And we'll explain exactly what that means in a minute. And we call that CZML. And at that level, no coding is really involved. It's just a format. Think of it as KML to Google Earth or Google Maps. CZML is to Cesium. You load data in and you're ready to go. So that brings us to the next question as, what is CZML? Well, it's first and foremost a JSON schema. You parse it with JSON.parse. It's no different than any other JSON object. You load it in. It's how that data is laid out and what you can get out of that data that's important. And in this case, the differentiator is you can accurately describe data over time. So while a JSON object, usually here's a list of properties associated with this object, the CZML object says here's a list of properties associated with this object and how that object changes. So for example, if you were modeling an aircraft, you could give us position and orientation of that aircraft. And then also, because we care about visualization, give us the graphics, the labels, the markers, the models, everything associated with that aircraft. And then how they change over time. Some of the other goals we had was to make it streamable. So you don't have to have a file up front. You have to, you can stream it down incrementally or have the server generating it on the fly and make it as optimized for clients as possible. We wanted web clients to be able to easily read it. And we wanted humans to be able to easily read it and write it. And overall, we want it to be an open and extensible format. We don't want to create a standard by just giving people something and say, here, it's a standard. We want it to be a standard because the community works together to make it one. And once again, it's easier to see these things than actually explain them. So I'm going to jump into another demo. And this is actually the Cesium Viewer, the same exact application I was running before, but now we're loading a CZML file into it. And when we load the CZML file into it, what's happening is the data from that CZML file is driving the visualization. So you see, now we have the same globe, but now we have some satellites moving around. We have Landsat GeoEye, which many people call the Google satellite because they help sponsor it and their logos on the side. And we have a Russian communication satellite, Molnaya, here. And this facility here, that's where I am in AGI. So you can see these things moving around in time. We can speed up animation. We can slow down animation. We can scrub back and forth. You'll also notice that as we pass around certain areas, there's some lines being drawn. And what we've done there is we've pre-computed when these objects can see each other. So when the ISS can see our headquarters, we now draw a line from the ISS to the headquarters. And that line goes away the moment that the ISS can no longer see it. And as I animate back and forth here, we can animate both forward and backward. You see that line coming and going. We can also, go into 2D and Columbus view mode, as we talked about before. So now when we animate, once again, this is one API. There was no code changes needed. And now we see from a visualization standpoint the height of these things. So the Molniya satellite is way up top, and all the rest of the satellites are much closer to the Earth. So it just gives you a different perspective with the same projection. We can speed up animation here, and you'll see the Molniya is going to actually zip around, come back, and go all the way out. So it just gives you a good perspective of what's going on. So that's just a simple CZML file. And we can go and look at a stream-based CZML file. So rather than load in data, this is a web application. It's not Viewer. It's a new application that actually just streams data on the fly. So in this case, we have about 1,000 different satellites, all over the world. And what we're doing is we're generating their position, and we're generating their orientation, and then we're streaming it down to the client. So there's no file involved here. And as you can see, performance is pretty good, and we have lots of objects coming down. We have a little bit more visualization. Not only are we doing that line of sight visualization we're talking about, we also have some sensors here indicating there's a camera on the satellite, and we're changing color. So colors and size of things, as things change over time. But once again, I can speed this up, I can slow it down, I can go back and forth. But it's not a file, it's all being streamed. So if I jump around to somewhere later in time, everything disappears, and now it's going to rebuffer, and now the data is going to pop back in. So just showing you that, yes, it's a file, but it's also a streaming format. So now that we talked a little bit about what CZML is, and hopefully you kind of have an idea, most people go, okay, well, that's great. You told me we talked a lot abstractly, but what is this format, and what does it look like? So I want to show you very quickly, let's bring up a simple CZML file. Let me shrink the font here. And so this is a CZML document. It looks just like any other JSON document that I'm sure you're familiar with at this point. And the difference here is that if you look at it, now we have this ID that says, okay, I'm an object. This is really just an array of objects. And so this ID has this billboard associated with it. And so far, there's nothing time dynamic here. We just have the scale of the billboard, whether to show it. This looks like any other JSON object. There's nothing really special about it. But when you get down into how it's laid out, things like position. So I'm saying the position of this object has a cartographic degree position, and here's the longitude, latitude, and altitude in cartographic degrees. Additionally, when we get down to the satellite, so here's that GeoEye satellite we talked about, we have this availability flag. And this is an ISO 8601 interval telling us the times for when that satellite has data. In this case, it looks like it's March 15th, 2012 to March 16th, 2012. So it's a day's worth of data. And then when we go down to describe the position, rather than having one position, this satellite now has a whole array of positions. And what we're giving it is an epoch, so telling us when the positions start, and then we're giving it what we call epoch seconds since that position, and all the new positions. So this describes the entire movement of the satellite. And as you see here, we're using satellites in this example, but it can be a car, it can be an aircraft, as you'll see in a minute. We also we can't send down all the positions constantly. We're not constantly streaming data from the server. The idea is to send down sampled positions and then interpolate client side. So here you can actually specify different ways to interpolate the data. Linear interpolation is the most popular. For space-based object, Lagrange interpolation is also used. And then there's a third option called Hermite or Hermite, depending on how you want to pronounce it. And those are the options we support there. And then I won't spend too much time in the text file because it's not exciting, but the one last thing I want to show you is the lines we talked about. So this is the ID for that polyline that was showing when things were visible. And now we have these intervals in here to show you, once again, here are the times that I want you to show it, and here are the times I want you to hide it. And that's what's being, that's how it's defining the show property. And then down here, we're actually not defining the positions of the polyline as positions. What we're defining them as references, links to other objects. So we can say, I want a line being drawn from this object to this object. So it's much more, that line automatically becomes dynamic, and the client can automatically update the endpoints of the line as data is being animated. So that's enough for looking at text files, but hopefully it kind of gives you a little bit of an idea of what CZML looks like, and it's actually pretty easy to read once you get used to it. So because we don't expect people to actually write all of these things by hand, we actually started another GitHub project called CZML Writer. And what that is it's a set of both Java and .NET libraries, APIs for writing CZML. And that's also open source under the same Apache license. You can do whatever you want with it. And on top of that, we thought it was important, you'll hear the saying content is king. It's important you can have the best render, best globe, best map in the world, but if people can't get data into it, it's not going to get used. So we wanted to make sure that CZML could be easily created from other formats. So we have converters for KML, for shapefiles. GeoJSON isn't done yet, but it's on the way. And I think we just added support for the Google WebGL Globe JSON format as well. And, so we want everything to be able to be easily converted to CZML, and we're in the process of writing a web service that'll be able to, drag and drop a KML file into the Globe in order to load it. All the code for the CZML writer is up on GitHub as well, so you can just go to the link and check it out. So here's some demos written with the CZML writer. This first one is just a converted KML file, and this is actually all of the airports in the world as of a couple of years ago, just a free KML file we found online. And I believe there's about 10 to 11,000 objects, and these are just static objects. So this could have been a shape file, this could have been anything. As you see, as we zoom in, there's all these little dots. We couldn't make them too big because, obviously we don't want to clutter the view too much. You can switch to that Columbus view and you kind of get a view of where everything is. We can zoom into Europe here. So that's static data, not very exciting to look at. Another demo we have here is much more dynamic, and I'm going to actually show you, we can actually drag and drop data onto the globe. So I'm just going to drag and drop this, and this is a CZML file being loaded, and whoops, that was the wrong one. One second. As I said, I'm just running off of our website, so I'm going to go down to our CZM viewer on the website. And so if you're working on, trying to write CZM yourself, you can actually just use our viewer online and drag and drop your CZM files in order to load them. So what you're going to see here is this is actually a 10-hour log file of all the flights coming into or leaving the United States in a period. So I'm going to actually shut off lighting to make this a little easier to see. And I'm going to speed it up. So now we're animating at 1,800 times real time. I'll slow it down to 900 times real time. And now you see these are color-coded by airline. And this is all the flights, like I said, coming from or going to the United States. And as you see, we have some in Europe and they're leaving and crossing the globe. And it's just showing how we can scale. There's a lot of data here. And once again, it was really easy to load into the client. And then once it's loaded, the CZML visualization itself can be really fast. And once again, we can jump around. So if I pause this, I can slide this back and forth in time, or I can jump instantaneously to another point in time. And you can see just how quickly we can kind of figure out where everything's supposed to be, hide and show the things that are supposed to be there and not supposed to be there. And once again, we can do this with a 2D projection. We can do it with our Columbus view projection as well. And you can do things like toggle on the lighting, toggle off the lighting, those types of things. So now we're just kind of looking at, just high performance, lots and lots of data. And our goal is this is actually a single file. This could also be streaming real-time data. You can build all kinds of applications with this. And once again, this is viewer. It's written on top of Cesium. CZML processing is part of Cesium. So the viewer is just kind of a GUI and a skin on top of everything. So we just looked at the FAA data. So the next question would be, well, okay, if we want this to be a standard, we want other people using it. So right now, Cesium supports CZML, but what about other projects? So we have a reference implementation that's obviously part of Cesium and part of the open source package. And we use asynchronous module definitions, so our code's pretty separate. And the CZML processing code is actually unrelated to the Cesium rendering engine, which means that you can actually reuse, I would say, 99% of the CZML processing code in an existing JavaScript-based application without any modification. So if you have your own, globe or map or own application that you would like to read CZML online, we're really interested in helping people do that and, helping people learn about the format and integrating it into other projects. So if you're interested, let us know, and we want to help. Finally, I want everyone to consider this a call for collaboration. CZML itself it's still a work in progress. We have some really good ideas. The latest specification is always up on GitHub at the shortened URL, git.io/CZML. You can also just get to it from our main page. And, go online, read it, tell us what you like about it, tell us what you don't like about it. We really appreciate any feedback you're willing to give us. And, we really want the community to help create this standard. We don't want to design it in a bubble and then try and get everyone to use it. We'd rather it become a standard because everyone is using it, because everyone pitches in and helps out and tells us what they like and don't like about it. And it's going to be an open standard. We're not, trying to retain control or anything like that. CZM itself, I'll say it's still under development, and we're always looking for good developers or artists or designers. So if you're interested in being part of an open source project, or you want to be part of another open source project, let us know. There's a lot of low-hanging fruit since it's a new project, so a lot of cool things you can get in on the ground floor on. And you don't even need WebGL experience if you're not a WebGL developer. We have lots of just plain programming that needs to be done too. So in short, I guess what I'm trying to say is we want everyone to come play with us, and we're really excited about this project, and we really want to help build a community around CZM and CZML that's part of the larger WebGL GIS community. Just some links to share. So out of all these links, most of these were already in the presentation, but I will comment that you only really need that top link, the CZM main project link on GitHub, and that'll get you to all these other links. So don't worry about writing anything down. If you search for CZM on GitHub, we should be the first hit as well. We also have 2 Google groups set up, one for development mailing list, the other for just our general announce list. So you don't have to be a developer to join either. If you're just curious and want to follow the project, please come on, join. If you see something you're interested in, you can chime in. That is all I have for a formal presentation. If anyone has questions, that'd be great.
Thank you very much, Matt. I don't know if you heard the applause. Are there any questions? We have time for 1 or 2 questions. You're all tired. Okay. So no questions at the moment.
No problem. Everyone's tired late in the day, I understand. It's only 9:30 here, so I just had my
So I wish you a pleasant morning, and thank you for presenting. It was very interesting. And
oh, thank you, and I hope to hear from some of you online. So
yeah, for sure, yeah.
Okay, enjoy the rest of your day.
Thank you.
Thank you.